Shall to proceed? Okay, we'll continue. Yeah. All right, I will share one video about subsurface safety valve. Okay, let's check this video. Can you make mute, please?
Yeah.
Okay, check this video how to open and close with hydraulic pressure the subsurface safety valve surface control. Here we apply pressure. This is the flow tube coming down to open the flapper valve. Here now is fully open. He will start now to bleed off the pressure. He start to bleed off here, bleed off point, flow tube up, then the valve is closed. Okay. Okay, gentlemen?
Yes, fine.
Okay.
Yeah, Mr. It's fine.
All right. Now we are going to talk about the perforated joint. If you look here, this is the perforated joint we install usually in the top of the string above the XN nipple. It is perforated, manufactured in the workshop, is not homemade, to give pass for the flow if the bottom for the string is plugged. This is one reason to use this perforated joint. And usually we install above the XN nipple, because the XN nipple we used as to hang gauges for pressure and temperature recording while flowing. So if this one is not installed, so the flow will come around the gauge, will start to vibrate the gauge to affect the reading or the data from this gauge. That's why we install that one, so the flow will pass from this port up to the string. This is the main job for the perforated joint, as we said, installed above gauge hanger in the XN landing nipple. Check these two figures. The left one is without perforated joint. So we hang one gauge in the red one in the XN nipple. So the flow will come, start make turbulence flow and vibrate. It can cause damage and affect the reading for the temperature and the pressure for downhole. If you install this one now with perforated joint above the XN nipple, we install gauge, so the flow distributed here from this point and from down, so no vibration, gauge is saved through data acquisition system for pressure and temperature while flowing. This is the effect if you not install the perforated joint. After that, we'll talk about the production pucker. Usually the production pucker isolate the annulus area from the fluid for the well, isolate the tubing from the annulus. So it does not allow communication between the wall for the casing and the fluid, gas or oil to not make corrosion or corrosion to the pipe or the casing wall. Okay, gentlemen?
Yes, Mr. Ahmed, it's fine.
There is two types for production pucker. The feature for the pucker, it can be slips to engage in the wall, inside the wall for the casing, and squeeze packing element to seal inside the casing and make the seal in its place. This is the feature for all types for the pucker. The pucker type can be permanent pucker, like the bottom pucker. It will be permanent. That means we install first. After that, we run the production. If you need to retrieve the permanent pucker, it's not non-retrievable. That means you need to mill, to drill and to drop to the bottom for the wall. After that, you make fishing operation. This is the first type, permanent pucker. Another type is retrievable pucker. This run part from the production string, like the top pucker here, is set by hydraulic pressure or mechanical, and you can retrieve and release with the production pipe. With overpull, then you pull out with the production string. It can be single or dual or triple based on how many string you have inside the whirl pool. If you have dual string, you will use the dual pucker, or triple string, you will use triple pucker. The pucker can be set by wire line, by signal, electrical signal, electric line, or by on the drill pipe or tubing set pressure or mechanical. Can be mechanical or hydraulic with pressure, or mechanical in vertical well by rotating. This one is DB permanent pucker. B, D refer to this permanent pucker, DB, and this one RDH, retrievable pucker. R is referred to retrievable. H is referred to hydraulic. That means set by pumping after you set nipple or drop ball below. This one is RH. This one D is dual. This one, and this one RH, retrievable hydraulic pucker. Permanent pucker, as we said, integral casing part and run.
What about DB?
DB, this is barrier, double barrier, something like this. This refers to the type. Each company gives some names. Is not something like retrievable. Okay.
Okay.
Integral casing part and run independently, can run in slick in wire in E line. After that, it can be removed or retrieved by milling operation, electrical wire line, or hydraulically set. This is hydraulic set. You drop ball in profile. You increase the pressure inside the string. So you start to break here shear pin. So the slips start to grip in the wall for the casing. After that, you put weight on the string. So the packing element start to inflate in its place to make seal in the wall of the casing. This is hydraulic set. Retrievable pucker, integral part of tubing, and run and retrieve with the production tubing, can be hydraulic or mechanical set. There is another type, it's called inflatable pucker. This type used usually with coiled tubing application or intervention application, set for zone or leakage interval to cover zone isolation or leakage interval. It's called inflatable pucker. Is inflatable with pressure from the inside the coiled tube. Do you use this type before? Inflatable pucker with coiled tubing?
No.
This is two set for pucker, top like straddle pucker, and bottom this isolate in certain area inside the casing, but is run with coiled tubing application.
Yes, I have ran it.
You ran it before?
Yeah.
Okay. Next slide is talking about what is the production pucker accessories. Usually the accessories of production pucker, like seal assembly or hanger, as you said here, as you see here. Here, this is the seal assembly section. The end for the completion string have some seal elements, packages, and there is in the top no-go shoulder. When you run with the production string, there is permanent pucker inside the hole with spool, okay, to accommodate this seal assembly inside its place. This is called seal assembly. So we sting inside the permanent pucker on top of the polish pour receptacle, which is called PPR. So attached on the top of permanent pucker to accept the seal assembly. This is the common type to isolate string from the annulus. So when the packing element come inside its profile, it is seal the production of the production pipe from the annulus. Another type is called anchor tubing assembly, like this one. It can run in the bottom 4 string with seal assembly also, and the string inside top bucker with anchor slips hang on the casing outside. If you look here, this is seal bore extension, okay, or polish bore receptacle PPR in the top for permanent bucker. You're running here with the seal assembly, you run and sting inside the seal assembly. How you indicate you fully sting? The locator on the top or no go will tag on the top for the PPR. That means all seal assembly here is coming inside its place. This is called space out for the string. Usually we don't keep the string fully engaged or at sting inside its place. We keep like a space out distance for string elongation due to production heating. So this is designed according to production for elongation for the string. If you have one element package or packing element inside its profile, that means we seal the casing from the string for producing. This another type. If you look, the seal bore extension here is below the permanent bucker. So we sting in, so the packing element will come inside its place also. This is another type. Here, the bucker here. So here it is the tubing seal receptacle, TSR, and it's coming inside the top of the bucker. So this is different accessories or different design for the well. Usually this is the most common type, and the space out, you need to have some space out according to the temperature for the well to give area for extension for the seal assembly inside the PPR section. This is the PPR, polish bore receptacle, and this is the locator, sting completely inside its place, and this is the no-go on the top. This is the permanent malleable permanent bucker, and below there is landing nipple. This is landing nipple, one section with the bucker. We're running on wire line. After that, we set here plug to set the permanent bucker. After that, we retrieve the plug. After that, we run completion to sting on the top of the PPR, and we start producing from the well inside the string. Okay, clear?
Yes, Mr.
Okay.
Ahmed, packer is run with run on landing nipple, or where it is run, or just with the tubing joints?
Permanent bucker.
Yeah, permanent packer and retrievable packer both.
Permanent bucker here is running first on the E line, wire line, okay? Or it can be run on drill pipe to setting depths. After that, you run with plug to set that one, then you release the drill pipe and coming out from the hole. After that, you run the seal assembly with compression string to sting inside the top of the bucker or BBR. Then you start to produce from the well. The retrievable bucker is run part of the compression string attached pin by box to the production string. According to depths, you are going above the perforation to set the bucker at, to isolate perforation from the annulus above, or casing above. Okay.
So you mean that while running a retrievable packer, you run the packer with the tubing joints and packer at the top, and then the tubing joint again.
Packer in the bottom Okay, and the production pipe above, according to the accessories you have. Below the pucker, the retrievable pucker, there is plug nipple for plug. You set and you set the top pucker or the production pucker.
Okay.
Okay. Usually the production pucker it will not run with the seal assembly in the same trip. The seal assembly it will run without retrievable pucker on the top. To sting out, you have to pull the string little bit to release the PPR, to release from the PPR the seal assembly. Then pulling out with the string to change. And this one will be permanently inside the wheel port. But if you don't have the seal assembly, okay, and you don't have permanent pucker, so you will run with pucker, with pipe and tail pipe below the pucker. It is retrievable pucker. You set in the depths, certain depths above perforation, and set by hydraulic pressure. After set plug below. After that, you retrieve the plug, set, and after that you produce from the hole. This is second scenario. But production pucker or retrievable pucker will not run with the PPR in the same trip. Because if you set the pucker, you will not be able to space out the seal assembly inside its place. You got my point? Clear?
Yes, as I understand that, so we have to perform 2 trips. Yeah.
Here, 2 trips. Yeah.
Yeah. Okay. First with the tubing joints, we run the packer, and then in the second run we will run the PBR.
PBR with the pipe, with tubing. Let me share the whiteboard.
Okay.
You can see the whiteboard. Not yet. Okay, here. Look here. This is the casing. First, I run permanent pucker with tail assembly, including here nipple. This one can be run with wire line, E line, electric line, and set by signal from surface, or it can be run with drill pipe at this depth. Okay. After that, I run slick line to set plug here, increase the pressure inside the pipe till I break the shear pins. Then I set this pucker and I pressure up the annulus to check the integrity for the pucker. Okay. After that, I will pull out, release tool. I pull out with the drill pipe. So what I will do after that, I will start to run with compression string. The compression string like this. It will have the top for the pucker here, have BBR. Polish pull receptor. Okay, like 10 or 12 feet according to the design. There is here profile for seal assembly. So this is, it will be the packing element on the seal assembly. The seal assembly here will be attached to our pipe, production pipe. After I run, I will start to enter the PPR area to sting inside. Okay, when this coming here inside its place, that means I sting in. It's called sting in. So the top of the no-go will have slack weight in the top for BBR. So I completely sting in with seal assembly. So now I can produce the well. Okay, this is the option. How I can release if I need to pull out again after I kill the well and open SSD, something like this, and this is a tubing hanger on the top, I will start to pull the string with overpull, so the seal assembly sting out from the PPR. The PPR is part of this packer. Then I need to change seal assembly or the pipe, then I run back again to sting in. So that one now is permanent packer. If I need to replace, I will mill. I will run with milling assembly to mill this one and drop inside the well. Then I fished out from the hole with fishing assembly. This is scenario. You have another scenario, well, like this, without permanent packer in the bottom. So I will run in this case with packer assembly. Okay, with steel pipe in the bottom, down to setting depths above perforation or the zone. So I will run to this depth and start to set my packer. After I run one plug below to set the packer. This is one is retrievable packer. When I need to retrieve, I need to make overpull on the pipe to retract again or release the packing element and slips out from the wall of the pipe. I wait some time for packing element to retract to normal shape. Then I start to pull out the packer with the pipe out from the hole. This is scenario, and this is another scenario with seal assembly. Understand? Okay.
So you mean, Mr. Aman, you mean in the second case, there is a temporary packer.
This temporary packer, production packer, retrievable one, to isolate the production, so the production comes through the tubing, and the annulus is filled with completion brine. After that, you test the packer to check integrity. Then there is tubing hanger at the surface and the Christmas tree. You start to produce by this way.
Okay, fine.
Okay.
So this this temporary packer would be hydraulically set or mechanically?
It is depend on the inclination for the wall, but most now packer, 90% from the packer now easy way to set hydraulic.
Okay, fine.
Okay.
Sometimes, Mr. Ahmed, sometimes we run permanent packers with tubing as well that are set hydraulically by means of a magnum disc, and we don't need to run LSA if we don't have the case for LSA.
Okay.
We usually run like a hydraulic packer, hydraulically set permanent packer with the tubing, and apply pressure with by means of magnum disc and in tubing, then apply pressure and the hydraulically packer the packer would be set hydraulically.
Yeah. Most of packer now set hydraulic.
If we don't have a case for LSA.
For what?
If we don't have any LSA, then
what mean LSA?
I mean that if we don't have a LSA in our completion, then
what
the packer would be run with the tubing.
What meaning for LSA? I don't understand this word.
Locator seal assembly, the short form of
locator seal assembly. Okay.
Yeah, LSA. If we don't have any LSA, then we would run packer with the tubing and set it hydraulically.
Yeah. This is the second scenario.
Yeah.
Yes. Why this scenario can be done? Why this scenario?
Which scenario?
This one. Why I run permanent packer here and the sting inside?
Since if we in that case, if we run the permanent packer with tubing, then we need to cut the tubing above packer and then we can retrieve it. In this scenario, in the scenario for LSA, we just need to string out the tubing string with LSA from the packer and just continue pulling out a hole.
Why
Retrieve the tubing with LSA.
Why I need to cut? Why I need to cut here?
No, I'm not saying to cut the tubing in the case for LSA or in the case for retrievable packer. I'm saying we need to cut the tubing when we set hydraulically permanent packer with tubing. We don't have any LSA. When we don't have any LSA.
Okay, we cannot run drill tubing inside the permanent packer without seal assembly. We cannot. This seal is very important to sting in its place. If you don't have this seal, so the flow coming like this and enter the annulus area. After you sting in with the seal assembly here in its place, you will pressure up annulus to make sure there is no communication. The seal assembly is sealed in its place after space out.
Yeah.
In case of seal assembly, you need to pull and stuck in its place after overpull. For sure, you will cut the pipe here. After that, you will make fishing operation.
Yeah.
In some cases. Okay.
Okay.
All right. Back to the presentation. Now we'll talk about the SSD, sliding side door. It can be called SSD or sliding sleeve. This can be designed for communication. It gives temporary communication between the string and the annulus for killing or displacing the hole with kill fluid. And also this one, it can be set between two zones. If you have multiple zones to select, when you open, you select, you produce from top and you close the bottom, or you choose to open the low one and isolate the top one like this. It can be provide selective zone production also. The SSD is features. You have nipple profile in the top if you need to install any plug, and there is profile here and seal port for the plug set, and there is flow port here with equalizing port, and the bottom here for seal assembly. So this one using opening and close with slick line with something called shifting tool with a slick line. Usually we place the SSD in completion above the retrievable packer by one joint at least. You leave one joint space above the packer, and after that you set the SSD. Why? Why I need to leave one joint like 30 feet space between the packer and the SSD? Any answer?
Yes, Mr. Ahmed, sorry.
Why I need to install one joint above the packer, space out between the packer, one joint, whole pipe, and then the SSD above?
To avoid any frictional forces on the packer.
To avoid any
Frictional forces on the packer.
No, it's not like
The floors.
No, I guess it's about the fluid. If we need to pump
It's about
the fluid from annulus to suction fluid.
usually this is the lowest point above the pucker, so install SSD in this point to circulate
From,
all the hole. But why I need to leave one joint?
Annulus to tubing or tubing to run.
Actually, the internet is very bad. I cannot hear you. Anyway, I will answer this question. We need at least to keep one joint 30 feet space out between retrievable pucker and SSD for two reasons. First reason, when the slackline operator run to open or open the SSD, after he open, he needs space, some space to go down the SSD to check it is free or not. So we need at least one joint to keep below the SSD and above the bucket. This is first reason. Second reason, when you start to circulate or kill the well through the SSD port, if there is any accumulation for debris or sand or any material accumulated in this area, it will become around the pipe, the body for the pipe. So it will not restrict the operating for SSD, and it will not restrict the closing for SSD again. It will not block the SSD. That's why we need to keep one joint space between the SSD and the pucker or retrievable pucker below. The SSD type has two types. One type.
I got your, Mr. Ahmed, I got your point of settling of solid particles in the annulus, but I didn't get the point for the slick line. Why do we need to run slick line below after opening or closing the SSD?
This is in opening, we need to pass from the SSD because the shifting tool, after shifting tool hang and open the SSD, there is shear pin broken, so it is engaged again. Disengaged again. So he need to pass below the SSD to be sure it's free inside the SSD after opening. This is this is procedure for the operator.
For the disengagement, we can run it inside the packer as well.
No, the packer little bit, it will be from ID is little bit smaller, so it is easy to pass through the tubing, not to hang on the packer. And the second reason for settling solids.
Settling of solids in the annulus. Yeah. Okay.
The SSD types, there is two types. One type is jarring up to open the sleeve. There is two internal sleeves, internal and outer sleeve. When the port is coming towards, that means the SSD is open. So it can be run with shifting tool, and after setting depths with jarring up to open, that's why it's called X or R U. U is referred to up. When you see in schematic for production, XU or RU, R and X is referred to the profile nipple here on the top. U is referred to the direction to open the SSD. This is up direction. Jarring down to open, it can be jarred down to open. That's why it's D. D coming from down, the word of down. X and R, the same profile for the top nipple to install any plug X or R. You can use several types for SSD inside the well, no problem. But all with the same direction, all up, open, or all up, down, to not make confusion for the operator for a slick line. Okay. Here, how to sliding side door open and close. This is running for SSD from beginning. It is run in closed position. So this is the outer sleeve and this is the inner sleeve, the blue one. After you jarring up to open, so the port here is come opposite the external port, so the SSD is fully open. The same, I will reverse upside down the shifting tool again, and I run to jarring down to shift this internal sleeve down to close the SSD again. That's why it's called temporary communication between tubing and annulus. The permanent communication can be happen with punching top pipe. Punching pipe, that means run to make hole inside the pipe. But in this case, it is permanent hole. We cannot resume production again. That means I need to pull out the string in workover or completion phase. Before opening the SSD, we need to equalize the pressure above and below the string, outside and inside, in annulus and at the opening port here. We need to calculate hydrostatic head at any surface pressure and calculate the hydrostatic head in annulus. If there is difference, we need to add some pressure at the surface to equalize the pressure before opening SSD. Why? To not make any jump or jerking for the tool for a slick line inside the pipe. If the pressure in the annulus above, when you open this SSD, the pressure was coming through the port will jumping up the tool for a slick line. It can cut the slick line tool inside the hole. That's why we need to equalize the SSD. After you close the SSD, you need to check it is completely sealed. In some cases, it can close not completely, little bit open. So we'll pressurizing up the annulus above the pucker to make sure holding pressure in annulus. So we are sure now the SSD is closed completely.
Mr. Ahmed, how big is the opening of SSD?
How much is opening? There is 4 ports, small 4 ports.
Yeah, the size of those ports.
I don't know
how big?
exactly because it is differ from one company to another. Exactly, I don't know exactly.
Okay.
But very small port. If the small port is plugged while circulation, you can see increasing or jumping in the pressure while circulation.
Yeah, got it.
Okay,
fine. Yes.
This is the shifting tool. There is shear pin and dogs here. When it is come down the sleeve, it will hang from the bottom and you start to jarring up to open the SSD. So this one is break, so it will retract again, so you can pull the shifting tool out. This is upper thread and lower thread. This is application for slick line. And in case if you cannot open the SSD for any reason, you can rigging up coiled tubing unit and attach to the bottom this tool to give you more power or more force to open the SSD which is stuck in closed position. Some types for SSD is hydraulic type. This one is mechanical one. You work with slick line to open and close. In some companies they use now hydraulic SSD. You apply pressure inside the well against plug, so the port will be open. And you apply pressure again, so the port will be closed. This is called hydraulic mechanism for the SSD. After that, here we'll talk about side pocket mandrel. If you know about the gas lift as a secondary production help or artificial lift, this one is running with the production string. If you have plan for gas lift, so each pocket here from side, there is place here in this area, this cross section for side pocket mandrel. To install gas lift valve, it's sitting at the surface according to the design for the gas lift at certain depths to one-way valve. You start to inject the gas, high pressure and annulus through the port in the gas lift valve, one-way valve. So the gas will enter the string, production pipe. So it will reduce the hydrostatic head for the oil. So help to produce the oil from the well. This is called artificial lift, called gas lift. you have several numbers here for gas lift.
Ahmed, how we open it? We also run slick line to open it?
Which one? Slick line? What means that? To install this valve with a slick line, yeah.
Yeah. No, to open this valve and then we inject gas.
No,
from
to
annulus.
open with the gas injection. There is port, the gas will pass according to certain pressure, so it will open the like flubber, something like nozzle or flubber. It will be open so the gas will enter the string or the production pipe. Okay.
Okay, through annulus only. Gas can enter it through annulus only, yeah?
From annulus inside the string to reduce the hydrostatic head or oil, then to start to flowing the well, help to flowing the well.
Okay, fine. So that means no other fluid can enter from that side.
No,
Only gas can enter, yeah?
only gas through the gas lift valve. The gas lift valve is expensive. If you don't have plan now for artificial lift like gas lift, and you produce with the pressure for the formation, so this pocket must be blocked. So we install here something called dummy valve. This one.
Okay.
Dummy valve, DV. The dummy valve here have two packing elements. It's hold the pressure from outside and from inside, from top and bottom. Each valve you can install here is set by slick line operation. Okay, in the top here, there is tool here called orienting the sleeve, where the kickover tool with slick line tool coming at this side to set and unset or retrieve the any valve. Also, the side pocket mandrel is port here. You can run circulation valve, one-way valve, to circulate the well or kill the well through the circulation valve, one-way valve. You pump from annulus to string, or the reverse to pump from string to annulus. This is called circulation valve. That's why for gas lift and also used for communication device also. Another valve, chemical injection valve. This set for chemical injection from annulus to string. If you need to inject inhibitor or something, differential pump kill valve or equalizing valve. This all valve is set by slick line tool. The valve size here is 1 inch or 1.5 inch in this area. That's why it's called side, because there is pocket in the side for this mandrel. It's called SPM, side pocket mandrel, or gas GLM, gas lift mandrel in some cases. This is the gas lift valve. We don't use gas lift valve for circulation because it is expensive. We use only the circulation valve, less expensive or cheaper than the gas lift valve, which is set and designed for gas lift injection or lifting. Here is the side pocket mandrel. This is the port where the gas injected from inside the pipe to lift the oil to the surface. This tool is called kick over tool or KOT. The kick over tool, can you make mute please? The kick over tool is a special tool, slick line. Please make mute. It is run inside the well bore to the bottom, then is coming up. So at the orienting the sleeve, there is arm here will extend out. So it is run to the side to set or retrieve the valve in the side pocket mandrel. I will show you one video now regarding to the kickover tool. You can see the video now.
Yes, Mr. Ahmed, we can see.
Okay, I will run. Orienting the sleeve. We run to install valve here. He pull up till he tagged on the top. Then the arm will be retracted, so he pulling out the kickover tool from the hood. Okay.
Okay, Mr. Ahmed.
Okay, back again to presentation. After that, we'll talk about the flow coupling and blast joint. Usually, the flow coupling is short section from pipe, but the thickness from inside is little bit high, thick from inside, like this point, the yellow point here. Flow coupling is designed to withstand the turbulence for the flow of the well after it passing restriction area. So it install above and below like SSD or flow coupling. When it is passed through restriction, it makes high velocity or turbulence. So the high velocity, it can start to make erosion for the wall of the pipe above. So we install this one above the restriction area. So the high velocity of the hole of the well will start to eat in the high thickness wall of the flow coupling. So I will extend by this way the life for my pipe inside or production pipe in the well. That's why the flow coupling is thick from inside, as we said in cross section here, to withstand internal erosion or caused by flow turbulence. Short tubular stainless steel heavy wall, installed downstream flow control device or subsurface safety valve or SSD. Any area you have restriction inside the pipe. Yeah.
But I guess seeing the picture of the flow coupling, its ODs also looks like a little bit increased. Its OD remains the same, just like a tubing, or its OD increased.
Same from outside for the tubing, but from inside you have thickness from inside, little bit high.
Okay, fine.
Okay, so it is used like here. We install here flow coupling. Okay, here you have any restriction. So after the flowing is passing, it will have turbulence. So I install the flow coupling here, above and sometime below. So when the flow comes with high velocity, it will start to eat this thickness. So I keep my pipe, normal pipe, away from any erosion. Okay, to protect my pipe. Blast joint is the reverse. The blast joint, from outside, you have thickness from outside, is not from inside. It will install across the perforation. When the perforation start to flow the fluid it will come with some depresses with high velocity turbulence coming out from the formation. So it will face this one. So it will start to eat or erode the thickness from outside the blast joint. So this one for external abrasive action from formation fluid. Usually the flow coupling maybe 1 meter in length and the blast joint around 20 feet. Okay, for flow coupling for internal erosion and the blast joint across the perforation for external erosion. Okay. Installed opposite to perforation. Open perforation is non-gravel back completion. After that, we'll talk about annulus safety valve. What is the meaning?
Mr. Evan, flow coupling, it means flow coupling would be installed upside and downside of the minimum restriction always.
Yeah.
Like we need to install two flow couplings
Yes, and in some
all
cases,
the time.
usually we install above. Why? Because the flow already passed the restriction, so its velocity will be increased above. So in some cases, we install one, it will be above. If you have high pressure wells or high velocity, you can install above stream and downstream. Okay, but minimum you need to have one above the restriction.
Okay, fine.
Okay. This one is annulus safety valve, ASV. What is the meaning for annulus safety valve? You know the subsurface safety valve is below the surface by 300 feet. It will cut the flow from the inside the tubing, right? To stop the flow in case of emergency. The annulus safety valve is the same concept to shut or the flow in the annulus area in case only you have gas injection or gas lifting in the annulus. You have gas lifting in the well, so you pump high pressure gas in the annulus. It's come from the port for the gas lift valve inside the pipe. What if now the wellhead is broken or leakage? So at that moment, the annulus have high pressure gas. It will start to release at the surface, which is dangerous situation. That's why in gas injection well, we install annulus safety valve. The annulus safety valve, this one which is green, we installed usually below the subsurface safety valve. And there is control line connected to the annulus safety valve. When I start to inject gas, the gas is coming through the port of the annulus safety valve, coming inside the pipe after that to lift the oil up inside the tank. If you have problem at the surface, you just bleed off the pressure for control line like the subsurface safety valve, so it will prevent the annulus in the gas and the gas in the annulus to escape at the surface. It will prevent the backflow to the annulus again. This one is usually installed one joint or two joint below the tubing safety valve. Okay.
So, Mr. Ahmed, it means like annulus safety valve is also a valve which assists kind of an SPM which assists in flow of gas inside the tubing. But if we have any emergency or any leakage at the wellhead, then it would pass the gas towards the packer side.
Yeah, it will prevent the gas in the annulus. If this one is not, you don't have. So the gas follow in this area down to SPM, right? Okay.
Yes.
If you don't have this one, all the gas in the annulus will be escaped at the surface with high pressure. But if you have this one, it will close by itself, prevent the gas to enter the annulus and escape at the surface. So the tubing is closed and the annulus is sealed at the same time. So annulus safety valve were developed primary for use in gas lift well, just for a special case. They are designed to retain high pressures hydrocarbon gas lift in the annulus in the event of lost integrity at the wellhead. After the control line, you release the pressure or cut the pressure from the control line, it will be fail safe again and close and seal the annulus area from the high gas well. Okay.
Okay, fine.
After that, we talk about the control line. Usually control line can be 1/4 inch or 1/2 inch, connected usually with subsurface safety valve from the surface for controlling, terminated across the tubing hanger to the surface. through the tubing spool, and you have control fluid inside the control line. We're running with compression is attached outside the tubing and clamped with the tubing outside while running on hole. There is external protector or clamp to connect the pipe with the control line 300 feet down the hole, or if it's attached also another control line can be attached through the annulus safety valve, as we said. Usually this alloy is used 316 stainless steel is used for sweet surface. The well is sweet, no H2S. For H2S, we need to add nickel and copper for sour surface here to against the protection from H2S or CO2. This is the material of the control line. Last thing at the top for the well, we'll talk about the tubing hanger. The tubing hanger hang all the weight for the strength of the compression is set inside its profile in the tubing spool. Set in tubing spool or tubing head spool. There is profile for the tubing hanger. Function is suspend tubing string with thread connection, isolate casing tubing annulus, have access to control line through the tubing hanger, and receive here back pressure valve and two-way check valve. The tubing hanger can be single string with seal assembly to make seal inside its profile, or it can be dual for the dual string, short and long string. This is the tubing head spool. In the top, the manufacturer for the wellhead is the same size for the tubing hanger and the same manufacturer for tubing hanger. If the tubing spool FMC manufacturer or Cameron, you will get the same manufacturer for the tubing hanger to match inside its profile. Okay. This is the tubing hanger. There is 3 connections for the tubing hanger. You need to check the packing element here before you're running. If you need to replace it, can be replaced. The top connection here, bottom connection, and there is middle thread. Bottom connection is attached to the string inside the well, compression string. The top here on the rig floor, you need to connect pipe so you can able to run from the rig floor, the tubing hanger, to its profile inside the wellhead. So this is called landing joint. Pipe to run the tubing hanger to the bottom or to the ground level as the wellhead. The middle thread here is for attached the back pressure valve or two-way check valve, and usually this middle thread is left hand thread. That means if you need to tie it, you will make left rotation to attach the back pressure valve and two-way check valve in its profile. This is the tubing head spool. Here the tubing hanger set, and this one is called lockdown screw. Usually after the hanger is set inside its place, you start to screw all this set screw to the maximum to indicate it's come in the top for tubing hanger, indicates that the tubing hanger is set properly in its place. Okay, this is 2 side outlet valves, or outlet connection, where one valve, manual valve 2116 is attached, so you can monitor the annulus between the tubing string and the surface casing from. This one is tubing head spool, ABB Vitco, this is the manufacturer. 11 by 11, that means internal bore for the top flange and bottom flange is 11 inch ID. 3K, that means 3000 PSI working pressure. So we need here tubing hanger 11-inch OD, 3K, matching with ABB Vitco grade to sit inside its profile. Same time, 3.5 tubing hanger. That means the connection for tubing hanger, top and bottom connection, is 3.5 EUE, for example. This is how we specify the tubing hanger. Clear?
Yes, it's clear, Mr.
Okay. This is the pack pressure valve, PPV. Usually is one-way valve. Install here cross section and tubing hanger in the middle profile with running tool with lubricator on the surface on the top for Christmas tree. So this one you can pump it through, can open, but is holding pressure from below. So it is one-way valve. It can be able to withstand differential pressure up to 15,000 psi. That's why it can be classified as a barrier. If you set back pressure valve and inflow test, that means I will bleed off the pressure above the back pressure valve to have pressure from the hole, and I test by negative way, so I can consider this one as one barrier. If you need to make a change or in tubing in Christmas tree above valves, or you need, for example, to nibble down Christmas tree and nibble up BOB. The another one is two-way check valve in the same profile here. This is the profile set in the middle for tubing hanger. You have packing element here to make the seal in its place. You need to check also these two seals from beginning. And this one is called two-way because it is hold pressure from top and from below. So you cannot bump through that one. If you set in its profile in tubing hanger, you use this one as barrier to test only the connection if you change any connection or valve in the Christmas tree. Used when the tree is pressure tested. Again, is this two-way check valve and can be withstand differential pressure up to 15,000 psi. After that, we'll talk about the wellhead. The wellhead, you know, it gives you some function like anchoring and connection for each individual casing, set with casing hanger inside the casing spool, pressure isolation. You can monitoring annulus pressure, isolation for annulus, connection for compression string, connection to the Christmas tree, allow access to annulus for pressure monitoring or bumping. There is two types for wellheads. The surface one, which is conventional wellhead, and there is another type, it's called compact wellhead. This is for subsea application. This is the compact wellhead where the wellhead is set in the seabed. So this one above, we rigging up or install the subsea BOB. Conventional wellhead like this. Here you have different annulus. This is the Braden head where the surface casing is hang. After that, this is casing spool, and this is the top one is the tubing spool where the tubing hanger is installed with where this one is the production pipe. So the annulus A is between the surface casing, and it gives you this annulus between the surface casing and production pipe, and each annulus give you the casing with the previous casing, give you monitoring the pressure while production from each annulus point. This is double studded adapter flange. This is the connection between tubing spool and the Christmas tree from the top. That's why it is adapter, because it changes the size. For example, from 11-inch down up to 318. So the Christmas tree will be here 318 size, or 7116 for water injector well. The Christmas tree is bigger, 7116. 5K, it is rated working pressure for the double stud adapter flash. Christmas tree is the top for the well. It gives you access or routing for the production coming from the well up to the surface line. There is some valves for the Christmas tree. You have top valve, which is called crown valve. Which is called crown valve, or in some cases it's called well intervention valve. Referred to, this is first valve closed after well intervention tool coming out above the Christmas tree. Yeah.
So
Yeah, go ahead.
no, I was saying, Mr. Ahmed, it also we used to call it swab valve.
Sorry?
We used to call it swab valve.
Swab, yeah. This can called swab valve, SV, or crown valve, or in some cases they called well intervention valve. Why well intervention? This is manual valve. This is first valve to secure and close the well after the well intervention tool coming out from the hole above the Christmas tree. Okay.
Okay, fine.
This one is production valve
Yes.
or flowing wing valve. You have a choke here to choke the production. The valve for Christmas tree, all valves is not designed to choke the flow. The choke, according to the API, must be done through the choke itself, choke valve. Okay. Here you have kill valve to connect external source for pump if you need to pull head. And this is two valve. One is master valve upper master valve, and lower master valve. The lower and the upper in some cases can be manual valve, gate valve manual, or in some cases the upper master valve is hydraulic valve or pneumatic valve. That means it's operated by hydraulic pressure. Do you have the hydraulic valve, upper master valve?
Yes, Mr. Ahmed, we have seen hydraulic master valves.
Okay. The upper master valve, it is emergency valve. Used in some cases, as we said, it can cut the slick line wire if it is equipped with cutter blades on its gate. You need to check the manufacturer for that one. Only a slick line, single wire. Okay. This valve, lower master valve, is manual, not working valve in optimum condition. What meaning? This one, while production, while intervention, usually is kept in open position. Why it's kept in open position?
Since we have a wire line or slip line or coil tubing inside a well, that's why we keep this valve open.
No, I mean after the wire line is coming out, we don't close that one.
For since well is flowing, if we want to shut in the well, then we will close this lower master valve. Otherwise, we would just shut the swab well.
No, this is the last option to close the well from. Why? Because this one, the last source to close if you have any leak in any valve above. But if you start from beginning to open and close the valve, with the time, this valve can be leaked. If this valve, it will leak, that means you need to pay more to set plugs above to change that one. So that one is kept in open position all the time during any operation, because this is last option to close to repair any valve above.
Okay, fine. This is some kind of a backup valve, so that if we have any leakage on the above valves, then we can close it and rectify the leakage above it.
Yes, yes.
Okay.
All valve here usually is gate valve, and this valve is not equalized by itself. I mean, if you need to open the valve, as we said, you need to equalize the pressure above and below to not cause damage to the stem or the valve, or to not cause problem to any tool above or above the valve. If you have wire line here and you open this valve under pressure, the pressure was surging up, it can cut the slick line and lubricator. That's why we need to put pressure on lubricator equal to the pressure of the wellhead. Then you start easily to opening this valve easily, and you start to run inside the well. When you all valve is this one, hold the pressure from direction of the flow. It's not from top. You apply, when you test this Christmas tree on the ground, you test from bottom. You close this one and you start to pressure from bottom, from direction of the flow. The same for the wing valve. By this way, you extend the life for the Christmas tree valves. If you apply pressure from the top, with the time, the valve or the gate valve, it will start to leak. Okay? When you close any valve, yeah.
So, Mr. Ahmed, doing a pressure test of our intervention equipment like slick line, wire line, or coiled tubing against valve is wrong?
During the pressure test, you close that one
Yeah.
to make pressure test against, right?
No. For the pressure test of intervention equipment like slick line, wire line, or coil tubing against swab valve is wrong, or
Yeah, it's
we
wrong.
can-
It's wrong procedure. That's why we need to install additional valve above this valve. So the pressure will be above the additional valve on the top, and after that you remove this valve. So still your Christmas tree is not affected by the pressure test. This is the best procedure, especially if you
Okay.
have long work time for the coiled tubing or slick line. Okay, or in the coiled
Okay,
tubing
Mr.
there is another option, is called two isolation valve. You install above the Christmas tree direct.
Yeah, isolation valve, yes. We
The
used to
isolation
install it
valve,
above the Christmas tree.
yeah, it is to hold the pressure from top and from bottom to
Yes.
make pressure
yes, sir.
against. Okay,
Yeah,
when you
yes, Mr.
close
Ahmed.
the valve here, and you need to pressure test from below, after you turn to the maximum the valve to close, you need to make it back like quarter turn. Why you do like this?
To avoid yeah, I usually adopt this practice, but I don't know why we do this.
Why? What do you think?
To avoid any what I would say the
To
to avoid
avoid,
any stuck of that wall.
yeah, to avoid pressure lock. So that's
Yeah.
why you keep it little bit one half turn to the left back to avoid pressure
Yeah.
lock after you pressure test the valve. Okay. You need also to check how many turn for each pump freely. It is it is vary from the size to another size of the Christmas tree. So when the Christmas tree come first time, you check the pressure test for this, and you need to count how many turn to fully open and fully close for each valve. Usually all valve will be same. Why we do like this? Why we need to know the number for turns for open free and close free?
So, sorry, Mr. Ahmed, can you please repeat the question?
This valve, you turn
Yes.
many times to close completely and you open,
Yeah.
right? Why
Yeah,
I need
yeah.
to know the freely count for turn for the valve for the Christmas
To
tree?
ensure that the well is fully opened or closed.
Yeah, to ensure while working with well intervention operation, there is no
Yeah.
stuck tool across the Christmas
Across the
tree
walls.
for any reason. So if you turn numbers is not the same for free turns, that means there is something hang inside or across the valve. Okay.
Mr. Ahmed, if we rig up intervention equipment on the Christmas tree, we would rig down our equipment with two barriers. So the first barrier would be IS valve, and the second barrier should be the swab valve. If we don't have any IS valve, then we need to shut the well in. So what would be the good practice to shut the well from upper master valve and from the lower master valve? Sometimes we have a Christmas tree where we don't have any lower master valve. We have directly the one valve of master valve. Like we have only one master valve.
Okay. So for sure you will close the lower master valve.
Okay, okay. Then we will close the swab valve and the lower master valve for
Yeah.
having two barriers.
Yeah. All
Okay.
all valve in the Christmas tree is considered as a one barrier.
Okay, okay.
All
So,
valves is one barrier.
okay, Mr. Ahmed, is there any practice like how many barriers should be there for rig up or the rig down of intervention equipment? There should be two barriers or three barriers.
For rigging up,
Yeah, for rigging up the intervention equipment like slick line or wire line or coil tubing.
no need for any barrier. Only the Christmas tree is the only barrier now to shut in the well. No
No, no,
need.
I know the Christmas tree would be the barrier, but how many barriers? Like we need to have two barriers of like swab valve and Christmas tree, swab valve and upper master valve, or we can rig up only by closing the swab valve only.
Only you close valves for Christmas tree. That's enough. Wire nipple up the cold
No,
tubing.
what I'm
That's
saying, what I'm saying, do I need to close the lower master valve as well, or I can rig up my equipment by closing the swab valve only and allowing the flow well to flow towards the flow line?
actually it is up to you. You have to choose to close. I close the top one for sure, and I close
Yeah.
one from the bottom.
Okay, so it means that we need to have two barriers at least for rigging up the equipment for intervention.
This valve is two valve here is not considered as two barrier. All valves here is one barrier because it is in one body. When I close this valve and this valve, I still have one barrier here. Christmas tree valve. It's called like this.
Okay, okay, fine. Okay, you mean that if I close the swab valve and the lower master valve, then I would have only in this case I have only one barrier.
One barrier but double protection.
Okay, 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 okay. So
Okay.
how many protections do I need to have before rigging up the equipment of intervention?
For well intervention, if you have high pressure well, for sure you
Yeah.
close one for this valve and top valve. After
Yes.
that, you will open that one, apply pressure on the top here for equalizing. Then you open, you will start to run inside the well.
Okay, okay, fine.
Okay.
Thank you.
During production phase here, if I need to pressure test the Christmas tree valve during operation, right? Before the well intervention job, or before I move the well intervention tool or equipment to the location, I need to make sure I will check the integrity for Christmas tree valve to make sure there is no bubbling or leak or oil or gas from these valves. This is one job of crew called well surfacing crew or well integrity crew, okay, and give you documentation that this valve is holding pressure integrity way. With integrity, that means with the pressure for the well, we make sure all valve, I bleed the pressure above and check integrity for each valve. This is mandatory before you start or moving your crew or equipment to the location. Okay, if you have any leak, they will adjust before the well intervention equipment arrive the location. When you arrive the location, you need to make also double check. So you will open the lower one, the top one is closed, and there is gauge here to make sure this one is holding. One by one to check the integrity again for Christmas trees. This is mandatory before you start your job. You need to inspect and check the integrity for Christmas tree valves, including also the two valve at the wellhead, the casing valve. Check also its integrity. It's not leaking pressure, or it's not leaking oil or gas, especially if the well contain H2S gas, okay, or percentage for H2S. You have different type for Christmas tree. The most common Christmas tree here is the flanged type. There is ABI flanges, so I can break here this flange and change one valve anytime I need, or you can change all valves one time as new Christmas tree. And there is another types for Christmas tree is called solid block or mono block. This is contain fewer component or connections, usually for high pressure well. And there is another type is called horizontal Christmas tree. It can be used in a restricted area in the height, or it can be used on offshore. This is the horizontal Christmas tree. If you look here, you will find kill line and manual valve and check valve in the side. There is nothing on the top, so less in the height, especially in subsea completion. And this is tree cap in the top, and there is two plug here on the top of the tubing hanger. This is the tubing hanger, okay, and this is the two plug, so the production come from the well to the wing for production. This is the kill wing also, and this is the AV or annulus valve. So the space for horizontal Christmas tree is small in the height. It can be used in application for surface Christmas tree or for subsea completion. In subsea completion, when you pull out, you remove the tree cap, you run the slick line to remove the two plugs here. Then you start to pull out the string without removing the Christmas tree. Okay. You start to pulling tubing hanger with the string through the Christmas tree. The Christmas tree will not change in the subsea completion.
Okay.
This is the monoblock or solid block Christmas tree. Do you have this one in your field? This type for Christmas tree?
Yeah, I have seen this one in some old wells.
Okay, this types for Christmas tree, if you look, the 4 valves here, or 5 valves in the same block. There is no connections here, ABI connections between valves. Only you have fewer connections just for kill line and for production line. This give advantage in case of you have high pressure gas well, so less risk for leakage. That's why we use this type. It's called mono or solid block. This is the main advantage. The main disadvantage, if you have problem of one valve, you will take all the Christmas tree out of surface to replace it, because you cannot separate one valve from another. Okay, that's why it is more expensive than the flanged API Christmas tree. This is the API flanged Christmas tree. All connections now for Christmas tree, according to the API, must be API flanged. In the past, there is a screw type. Actually, is not recommended according to the API, like screw connection. And another one is combination between flange and the screw. Actually, screw is not recommended now because of the high possibility for leakage. The API now is talking about we need all Christmas tree to be API flanged. API flanged, this is the policy for most company now. When I start to specify 918 5000 PSI flange, I mean 918 is the internal bore diameter, inside diameter for the flange, with 5000 PSI is the maximum or rated working pressure for the flange. This is recommendation according to how to select the Christmas tree. ABI 6A, this is the name for the ABI recommendation. If you look here, this table comes from 6A. It's talking about the manufacture and testing and how to choose the Christmas tree. If you look here, this is the well type, water, oil, and gas, working pressure. And this is the type for flange or monoblock. If you look here, the monoblock will start to use an high oil well, 10,000 or 5,000. And on all gas well, you need to use monoblock because less connection for less risk to leak. Flanged here, recommended to with high water well and 5,000 PSI. This is give you some recommendation to follow as a standard. This one is dual completion Christmas tree. You have two parts here, each section for one pipe. There is short and long dual string. So it's passed through dual hanger, as we said. So each string you can control from one side. This is the right, for example, short or long string. So you can control the production for each string inside the well. This is valves here for short string, and this is for another string inside the well bore. And you can control the well intervention operation when you're rigging up your coil tubing above this section to run inside only one selected string. This is the 3-gate valve. Is usually all valves is gate valve. When you rotate the stem, okay, the gate will move up and down to close and open through its place or its seat. This one is the upper master valve, actuator valve or hydraulic valve. It can work with hydraulic pressure or pneumatic supply system, air supply system. Usually this valve is upper master valve. If you look for its design, this one is open pass for the flow. You apply pressure here from the top hydraulic pressure. When you release the pressure, this spring will come out up, so it will retract again the blockage here for the seat. It's come inside its seat to stop the flow. This is an open position, and this one in closed position, working with hydraulic pressure. For any reason, during well intervention operation, like coiled tubing, we cannot rely only on the hydraulic pressure. And the hydraulic pressure at surface can be released for any reason. That's why there is one operator monitoring the pressure for the hydraulic valve. But I cannot guarantee on this pressure for hydraulic system only, because if this pressure for any reason bleed off or released, so the valve will start to close on the coiled tubing inside the well. It will cause damage to the coiled tubing and maybe cut, and will stop the operation and will complicate our operation. So how I can control this operation for coiled tubing while I working with this type of valve? What you should do? You work before with coiled tubing with this valve?
Yeah, we work with hydraulically operated upper master valve.
How you make sure before you're running this valve for any reason accidentally will not close on the coiled tubing? I need double protection. I cannot rely on the pressure only for hydraulic system.
We can open it manually as well.
No, it cannot open manual. There is no gate
Yeah.
in this valve.
Yeah, there wasn't on that Christmas tree as well.
Do you know about visible cap or lock cap like this one?
Yeah.
At the end for this shaft of the piston, okay, you
Lock
lock
it
this
manually.
one manually. You have cap,
Yeah.
so you screw this cap at the end for this area. So when
Yes,
the
yes.
pressure is released, hydraulic pressure is released, this valve will not coming back to open. You have lock
Yeah.
here at the surface, so it will prevent the spring or the valve from opening, from closing, sorry,
Yes.
to this
Yeah.
position. So that's why you close at the end. It's called visible cap or lock cap. You need to manual lock.
Yes.
Okay.
Yes.
This is the procedure. You need to have double protection to make your operation safe.
Yes.
Last thing in the for today, it will be wellhead connection. What is the API connection for pressure control equipment or for the wellhead? This one, the flange, cross section and the flange. When I mean ID, this is the bore for the ID. This is the area for the groove for the ring gasket. This one ring gasket PX 155 steel. So you have two API flanges type. One is called 6P and another type is called 6PX. What is the difference? The rated working pressure for 6P is low, up to 5K, 5,000 PSI. 6PX is up to 20, from 5 to 20K. Okay, this is the difference.
Yes.
This one is take ring gasket, use ring gasket R or RX, but with flanges 6PX is take PX ring gasket. The ring gasket, it's only one use. It's not reused again. Why the ring gasket we cannot reuse again? Even it is visually in good condition. Ring gasket is metal to metal seal, right? Between two flanges.
Yeah.
Why if I torque the flange and again disconnect, I need to change the ring gasket with new one, even it is in good condition visually.
I guess there is a groove in the in VX gaskets. Whenever we tighten the flange with VX gasket in its place, then there is a deform where VX gaskets always deform whenever the flange is tightened.
When you start,
There is a V-pole as well.
Yeah. When you start to install the ring gasket and you start to torque the bolt, the ring gasket start to deform inside its profile or groove. Usually the ring gasket material is softer than the groove, so it will take the shape, so there is little deformation happen. That's why we need to change it with new one, even it is in good condition visual. Okay. If you look here for two flange, after you make torque up for the faces of flanges, 6P flange, there is a standoff or a space between the faces of two flange here. This is the ring gasket area. Okay, but for 6PX flange, after you make tight and torque for the faces of the flange, there is no standoff or space. That's why it's called face-to-face flange. Which one is better according to well control? For sure, 6PX flange is risk for leakage. Okay, this is the difference. Any flange, any ring gasket end with X, it is called self-energized pressurized. What meaning for this one? There is in the ring gasket from inside, there is port, small port or holes. When you apply with the hand pump pressure to pressure test the flange seal, so this port will take some pressure, so it will make more seal in its place. That's why any ring gasket is expensive for RX and PX compared with the R ring gasket. Okay, gentlemen?
Mr. Ahmed, can you please explain our gasket? Like we usually deal with the BX type of gasket since we have all the equipment of 10K rating, but we usually don't deal with the gaskets of R type. So what is the main difference between the R type gasket and the BX type gasket in terms of their shape or
Yeah, in the
their
shape. In the shape, R have different shape, octangle
yeah.
and the square. There is different in the shape for the ring gasket itself. But RX and BX is the expensive than R ring gasket. That's why in some cases with 6P, the cheaper one is R ring gasket to use. Because I said the RX and BX is self-energized. There is small port to take more pressure while pressure test the flanges with the hand pump. This is the only difference between R and RX and BX. It's the shape for the flange itself. When you make tight for the 6PX, the flanges, the ring gasket itself, it is come inside the profile. Okay, so there is no distance here between the faces of flange. But in 6P flange, when you tie the ring gasket here with the flanges, there is a space here, standoff area. Why? Because this is the area for there is no groove. Especially after tied, the groove will not take all the ring gasket inside. So the ring gasket is still between, you can see between the two flanges, top of two flanges.
Yeah. Yes.
Okay.
Okay. So there isn't any groove. There isn't any port in the R type gasket.
No, there is no.
Okay. Okay. Fine.
Okay. So any questions for today, gentlemen? We finished the equipment part. Any question?